Welcome to our third lesson in machine learning and artificial intelligence. This is the lesson that will lead you into the world of AI. All the AI you've been hearing about in the world, all the AI that is changing the world, this is how to learn it. And in this particular lesson, you will be equipped to understand the basics, the fundamentals of AI and machine learning, and you are going to have the follow with us through the journey to grow and build a solid foundation in machine learning and AI and actually advance into the advanced levels of deep learning, neural networks, transformers, and large language models. This is a very powerful lesson, and a year from now, this is going to be required almost in every industry. And a lot of fields are going to include machine learning. For us in data, it is part of us. Whether you are a data analyst, whether you are a data scientist, ML engineer, or AI engineer, you will need machine learning. So this is a time to learn it. We don't want a year from now to start the journey, because a year from now, you will wish you had started today. And we are happy to start today, and we are going to be experts a year from now. We are going to have roles in this a year from now. What we are learning today is going to open doors for you. What we are learning today is going to really make a difference, make you stand out, and make you earn more in the field of AI and information technology. In our previous lesson, we started looking at the types of machine learning, and very soon I'm going to be asking you to tell me the three main types of machine learning. And in this particular third lesson, we are going to focus on semi-supervised learning and reinforcement learning. This is super exciting. And if you missed the first two lessons, get it from our set of videos. Ask Benedine to get it for you and just catch up. You are not late at all. And you'll find that they are very easy to understand. If you follow and really follow the lesson, you'll find out that you can really understand it. Don't let anything here be intimidating to you. As a matter of fact, this is really exciting, and you have to be really happy to add this to your knowledge. And I can't wait to go through this so that we can improve our knowledge. Let us be hungry to upgrade ourselves. Let us be hungry to improve. Let us have that desire to learn more. And after this particular lesson, your knowledge in AI and machine learning is going to improve. Never give up on a dream just because of the time it takes to accomplish it. The time will pass anyway. This is so powerful. This is so powerful. I remember a friend so many years ago who always wanted to learn IT. He knew that I was in IT, and he always wanted to learn. He always wanted to learn. He always wanted to come over to my place and learn, come over, spend some time with me and learn. And he always said it that he wanted to. Sometimes before we realize it's 3 years and it's the same story. And he tells himself, if we had started back then, like by now, I would have been better. And he keeps saying it. Listen, the time will pass anyway. 1 year will pass anyway. So don't give up because of the time it will take. Let's keep doing it. We will get there. 1 year from now, you will see everything come to pass. You will see where you'll be after 1 year. Let this apply to all your dreams, all your visions, all your projects, all that you want to achieve. The success you want in life, the wealth you want in life, it comes one day at a time. It will not come all at once. It comes one day at a time, and sometimes it feels like it won't come. Sometimes it feels like you will not make it. Sometimes it feels like you will fail. And sometimes you will actually get into trouble and you will have battles to fight. But guess what? One day they will all come together All your little effort will all come together and you are going to be abundantly successful. Please type that in the chat. Abundantly successful. Abundantly successful. Let me see the first person to say that. Abundantly successful. I want to see the first person to put that in the chat. Thank you, Marasi. Abundantly successful. So let's keep doing it. Every day, let's keep doing it. Every day, let's keep doing it. Every day, let's keep doing it. And we will make it. Our goal here is to build the best data analytics and data science team in Africa within the next 3 to 6 months by building strong foundation in data skills, mastering cutting-edge techniques, leveraging innovative tools, and leading Africa's AI research and development. Very soon, we are going to launch Afrique AI. If you've not heard of it, it's an innovative machine learning model from Africa, an AI model from Africa, and it's coming out right from here. Yes, right from here. Yes, and in our ML class, I'll just do a very quick recap of what we studied previously, very, very quick, and then we get into the lesson for today. And so we understood that ML is AI. So if you've been hearing of machine learning is artificial intelligence. And artificial intelligence is part of computer science, and it's the branch of computer science that seeks to make intelligent systems that can autonomously act, learn, make decisions. And there are several techniques to achieve AI. And as we advance, several techniques are coming up. But one major technique is how AI is built using data. How AI is built using all the data in the world. That is one powerful way to build AI. And most of the AI we know in the world is created that way. The AI we know, they are built through data. And so the field of AI that is built through data is called machine learning. Or machine learning is a field of AI that allows systems, machines, computers to learn from data. There's a way the systems learn from data. There are algorithms that are already created. All you have to do is to select one and then train the algorithm with data. Once you do that, you have a model and an intelligent system called AI. Inside the field of machine learning, we have another field called deep learning, where the algorithm you choose to use is one special one that is called neural networks. If you use neural networks to do your training, then you've entered into a whole new realm, and you've entered into the realm of deep learning. These AI systems can make predictions, decisions without explicit instructions. Decades ago, we built software by giving instructions, by writing instructions. We have seen that as data is growing rapidly over the years, and as events are happening, if we want to write instructions to cover every possibility, we will have limitations. And so we have decided to build systems that will not be given instructions. It's a conscious decision to build systems that will not be given instructions, but will be taught how to learn, so that dynamically, intelligently, they can do all the vast things through learning from a lot of data. And they can achieve more than what a human can. And this is the future of information technology and where the world is approaching. At the end of the day, you create something we call a model. And this model is an intelligent system that can analyze new data and make decisions based on what it has learned. So the field of machine learning is the field of training a model. Please type that in the chat, training a model. So all you have to do in this class is to learn how to train a model. In business, model training has become the most important task in most businesses to train a model for a business so that that model can make decisions, that model can take actions, that model can achieve results and help businesses grow tremendously. As you advance in this class, you will get into what is called business analytics, and you will apply everything you've learned to the world of business. All right. And so what you are learning today, you are going to apply it to the business field or the business environment, and you will use those skills to optimize business processes and make companies achieve tremendous success. So with the types of machine learning, I want someone to give us the three main types of machine learning. Let me see the first person to do that. The first person to tell us the three main types of machine learning. And we have learned that this machine learning, that is learning from data to build AI, there are three ways of achieving it. There are three ways of learning. So the field of machine learning, there are three ways of learning. And as you are advancing in this field, you need to understand the three ways, the three methods, and know how to build your models using these three approaches. All right. So when you hear of types of machine learning, all you have to understand is that there are three ways of doing it. The first way, according to most of you, is supervised. The second one is unsupervised. And the third one is reinforcement learning. We have spent a lot of time on supervised learning. We have spent a lot of time on unsupervised learning. And I think those lessons were amazing. If you missed them, please go back and get them. And today we will spend our time on what is called semi-supervised, because after you look at supervised, unsupervised, and reinforcement, there emerges another type that falls between supervised and unsupervised, and it is semi-supervised. And we will look at that today and understand it, because it is actually very powerful. And you realize that most large AI systems today are built using semi-supervised learning. Yes. Again, everything we are learning here in the types of machine learning is just telling us the three ways to do machine learning. All right. Each type has a distinct approach to how it learns from data. So based on the project, you know how to let it learn from data. We talked about supervised learning, where a model is trained using labeled data. With supervised learning, you need to provide data, labeled data to the model, or you train it with labeled data. For example, the data you will feed to the model, the goal of the model is to achieve a certain prediction. All right, to achieve a certain prediction. Okay, to achieve a certain prediction. Let's give an example of, let's say, the sales of a company. We want to know how much we'll be making in 10 years' time. And we want to build a machine learning model to do that prediction. So how do we do it? We're actually going to train this model and tell this model or teach this model how much we've been making for the past 10 years. Okay, so that is called supervised learning. I'm training you, but I'm giving you the answers of what I've been achieving already. Okay, so I'm not just giving you the data, I'm giving you the data with the answers. So study the input, study the variables, study the events, and then study the outcome as well. All right, so I'll give you the outcome. So you train the model with the events and with the outcome, with the features and with the target. Then after the training, you start testing the model by giving it only the events and checking if it can predict the right outcome. If it doesn't do it well, you keep training it until it does well. When it does well, now use it. Tell it to tell you how much you make in 10 years' time, and it will predict it right. Okay. So this particular diagram you see here, you can see that we have labeled data. This particular data set we have we are teaching the model, we are teaching the model, we are teaching the model that when you see this shape, okay, this is a model that will look at shapes. This shape is called a rectangle. This shape here is called a circle. This shape is called a triangle, and this is hexagon. So we use that to train our model. Okay, we choose an algorithm, and now we have a model. After we get a model, what we'll do is to test it. You can see that during testing, we didn't put the answer there. We asked the model, what is this shape? And because the model has been trained, okay, what machine learning is that after the training, this model is an intelligent system. It has knowledge. So when you send this data, it will look at it and it will make prediction. And let's see the prediction it made. It said that this shape is called triangle and this shape is called circle. It got it right because it has been trained with the correct answer. Just like in examination, you are tested after your training. During training, you are given the answers. But when it's time for you to produce answers during examination, you are not given the answers. But for you to get it right, you need to remember what you've learned and produce the right answers. Does this make sense to anybody here? Anybody at all? Does this make sense to anybody? All right. So this is called supervised learning, where you train your machine learning model with labeled data. You are not saying that this, tell me what this shape is or learn from this shape. No, you are telling this model that this shape is called a rectangle. This shape is called a triangle. You are teaching it the correct answers so that it will learn from it, so that later it will remember and produce the right answer. This is a very common type of machine learning model that we have in the world and you will be building. All right. We also have what is called unsupervised learning. Unsupervised learning is a type of machine learning where the algorithm learns from unlabeled data. Why are we saying the algorithm? Before you do the training, you choose an algorithm and then you train it with the data. After the training, it's no longer called an algorithm. The technical term for it is called a model. So now it becomes a model. All right. All right. So with unsupervised learning, we do the training with unlabeled data. Instead of training it with labeled data, as in supervised learning, with unsupervised, we are able to actually train models with unlabeled data. At first, you ask yourself, how is that possible? But this is how it actually works, and it actually happens most of the time, or this type of training goes on all the time. As a matter of fact, this is really the key to the modern AI we have. Okay? Ask yourself, the vast data we have in the world, how much time can we get to label all of them? When they were building ChatGPT and other AI systems, years and years and years and years prior, they were employing thousands and thousands of people to label images, label things, label things, label things, label things. I don't know if you heard of these remote jobs where you get a remote job and you are supposed to look at a picture and say that, okay, this is silver, or this is spoon, or this is that, just to label things. This was remote jobs that people were getting all over the world. I don't know if you heard of those kind of remote jobs. They got thousands and thousands and thousands of people to label things. But the thing is that we don't have all the time to label everything in the world, and data is being generated so much every time. And so unsupervised learning is actually a great solution to machine learning. How does it work? The algorithm is designed to find patterns or relationships in the data on its own. And so the algorithm is able to study and make prediction, but on its own. And as you advance, you are going to understand that there are different algorithms for different tasks. And so there are some of them that are able to study and make predictions without being told. In our previous lesson, we understood that this is how humans also work. As a matter of fact, were you taught everything you know? Are there some things that you learned by yourself just by observing and no one ever told you, but you got it right? Have you ever observed something and understood it before? Anybody in this class? Of course. Babies learn a lot without being told explicitly. Humans learn a lot without being told. Just through observation, pattern recognition, through observing relationships, you can just tell. It's not everything we are told, but we learn. Our brain is able to learn. We're able to learn. This is exactly what we are talking about. We have algorithms in machine learning that learn by looking at data and finding relationships. So when it studies all the data, for example, you can even give it your sales data and tell it to show patterns. It can look at the data and tell you what is going on, the kind of information it is getting by just studying the data, right? So here, all we are saying is that we can build machine learning models through unsupervised learning, where the algorithm learns from the data by observing and coming up with the right answers all by itself. And by looking at more and more data, it's able to understand. This is called unsupervised learning. And this is so powerful. This is so powerful. All right. An example is this. We have a model that is given a set of unlabeled pictures. Okay. The model never knows what these pictures are. But through studying these pictures, the model is able to group them based on similarities. And at the end of the day, it can group cats in one group and dogs in one group. Most of the time during unsupervised learning, most of the time, not all the time, the model is taught to do what is called clustering or grouping. And so by looking at the data, it's able to cluster them and group them based on similarities. This is unsupervised learning. Look at this data, raw input of pictures. All right. And as we advance, not only are we going to do machine learning with text data, very soon we'll start doing machine learning with image data as well. So this is unlabeled data. This time we are not saying that this is eggplant. We are not saying that this is onion. We are not saying that this is pepper. But this algorithm will just study the data. It will just study the pictures. And at the end of the day, through similarities and patterns, it's able to group them right. Look at the pictures at the right side here, the output. Tell me if it made a mistake. Did it make a mistake? Yes or no? Did it make a mistake? All right. It didn't make a mistake. It was able to do that. This is the real world of machine learning. And this is what we call unsupervised learning. The model is able to perform tasks and get it right without being told. Through observations, patterns, and relationships, it is able to do what is called clustering. All right. We looked at some key techniques in supervised and unsupervised learning, and we mentioned what is called regression, classification, and clustering. I'm giving this to you as an assignment, and you are going to write on these three. What is regression? What is classification? What is clustering? And you send your answers to assignments@rateafrica.com. Every assignment has records that will be added to your record. So please do this and send it. All right. We are going to discover how regression and classification belong to supervised learning and how clustering belongs to unsupervised learning. And you will find the similarities between them as well, especially between classification and clustering. So do this and it will help you retain some of the important terminologies that you are going to be hearing along your machine learning training or education journey. All right. Today, we want to get into what is called semi-supervised learning. Please type this in the chat for me. Type this in the chat for me, and we will continue. So this is semi-supervised learning. And this is going to give us a lot of understanding about this particular type of supervised learning. And of course, there are three main types of machine learning. And we are going to find out where this one fits and why it wasn't added to the main three types of machine learning. At the end of this short presentation, the goal is to find at least one person in this class who understands semi-supervised learning. I want you to pay attention and see if it makes sense to you and if it is something you understand. All right. So what is semi-supervised learning? Now, semi-supervised learning is a type of machine learning that sits between supervised and unsupervised learning. So with this particular type of ML, it is actually in between the two. How does it work? We know that supervised learning works with labeled data. And we know that unsupervised learning works with unlabeled data. Now, in between labeled data and unlabeled data, we have some type of learning in between them. With this type of learning, this is where we are usually dealing with a lot of data and we can't label all of them. So what we do is that we label a small part and we allow the system to do the rest. Because we can't do all of them. Semi-supervised learning, or SSL, uses a combination of supervised and unsupervised learning techniques to achieve the training data sets. It uses both techniques. SSL uses small amounts of labeled data plus a large amount of unlabeled data to help improve the learning process. How does it work? Most of the large AI projects that we have, we've already established that we can't label all the data. If we can't label all the data, does it make sense to label a sample and allow the sampled labeling or the sampled we have labeled to help the model understand the rest? Would that be a good idea? Anybody here? Would that be a good idea? Okay. All right. So V says yes, it's a good idea. All right. We have large amount of unlabeled data sets. We have been able to label some parts, but we can't label all. And so through the combination of labeled and unlabeled data, we want the model to actually do the rest of the job for us. Wow, this is really nice. This is really nice. I remember one software engineer who was doing some work. He realized that the work is boring, so he created an app to do the work for him. So he wrote code to do the work, not because he was contracted or anything, just to make his life easier. He wrote code to do the work. So this is like having a model to continue the labeling for you. You are supposed to label 10 billion data sets, and you label 1,000, and you allow the system you have built to continue the labeling for you. I think this makes a lot of sense. All right, let's see how this works. It's not that simple. So let's look at this diagram here, and please pay attention. If you get this part, then you've understood it. All right, so I'm looking for one person, at least one person, who will be able to understand semi-supervised learning. All right, so here we have what is called a large data set for model training, very big project. Okay, we have a large data set. Now, it is not practical to manually label all the data. I think we have established this fact. It is not practical. Most of the large AI models you know today, if you do the research, watch documentaries, you will realize the millions of people who have worked on it in the past when they didn't even know what they were doing. They were just tasked to label things and name things. Some of the tags they were given didn't even make sense to them, but they were just told to check names, make sure it's correct, label things. I remember someone from this particular class telling me that they were part of ChatGPT, but they didn't know it. Now, it is not practical to label all of them. All right, so let's get back to the point. So what we do is that we manually label a small portion of the data set. So the small data set you see over here, the small data set you see over here, we manually label it. After doing this, we use it to train a model. So use a label data set to train a model. Okay, let's look at it this way. We are training a model for the model to make predictions. All right. Because the data or the data set is so large, we actually label a small part and use the labeled data alone to do the training of the model. So after the model is trained with the labeled data through what is called supervised learning, what happens is that we use the trained model to predict labels for the unlabeled data set. To produce a new terminology I'm about to introduce, pseudo-labeled data sets. This happens in semi-supervised learning in a process known as pseudo-labeling. Let me explain it. We are building a model with a lot of data. We train part of the data, and we use that part that we have trained, or we have labeled, sorry, we label part of the data, and we use the part that we have labeled to do the training. So this is a normal supervised learning process. Okay, this is a normal supervised learning process. Okay, so if you understand to this point, please type 1 in the chat. But this is the first point. We are talking about semi-supervised learning, okay? And to achieve semi-supervised learning, we actually intentionally do a supervised learning. This means the labeled part of the data, we use that alone to do the training. All right. After we have done the training, we have a model, a supervised learning model, correct? Then we now go to our unlabeled data, okay? And we use the unlabeled data as test data for the model. Let me explain it this way. After a model is trained, it doesn't need answers to do prediction. As a matter of fact, the purpose of the model is to make predictions when given the inputs or the questions. Now, the unlabeled data is all questions with no answers. All right. So what we are going to do, we are going to use our unlabeled data as test data. Okay, because we have made sure that the model is somewhat intelligent. So we give our unlabeled data to the model we have created, and then the model will make predictions for us. But watch what happens. When that prediction is made, we save the answer and attach the answer to the unlabeled data. And so the data that was unlabeled, now it has gotten a label. But watch this. This label, it came from a model that we are still training. So we call it a pseudo label. Please type pseudo label in the chat for a pseudo label. And so we will use this pseudo label technique to label all the unlabeled data sets. To label all the unlabeled data sets. To label all the unlabeled data sets. And we are done. The unlabeled data set is also now labeled. Now, when we say label, we are talking about the data having both input and output, or both features and targets. In our previous lessons, we've established what features and targets are. The unlabeled data doesn't have targets, it has only features. It doesn't have answers, it has only questions. So we will feed those questions to our model that we have trained. And our model will give us answers. When it gives us answers, we will save the answers as it is. Because it doesn't come from real data and the answers are not verified, we call it a pseudo answer or pseudo label. But we use it anyway. So at the end of the day, all the unlabeled data is now labeled through the model that we built previously. This is where I look for those who are getting it. If you are getting it, please put 2 in the chat. If you are getting it, please put 2 in the chat. Okay. All right. Okay. Now, let's move on. At the end of the day, watch what happens. We use the labeled data, that is the first real labeled data, plus we use the pseudo labeled data that was labeled, the unlabeled data that was labeled. Now we call it the pseudo labeled data set. We use the two together as new training data as new training data to retrain the model. So this model that you see over here, this is the main training that it is going through. How is it being trained? It's being trained with this data and this data. And we already know that if you train a model, that's not the end. To make the model better, you have to continue training it. You have to retrain and you have to fine tune. And so at the end of the day, we have a model that is now trained with all labeled data. Sorry. It's trained with all labeled data. I know some people want me to say it again. All right. Thank you for that question. So someone says, what happens if some of the pseudo labels are wrong? Will the retraining not give wrong result? All right. So this is why we do the retraining with the correct and the pseudo data. Now, before we train our pseudo data set, we will actually make sure the model is quite good before we use it for that training. And so what will happen is that most of them will be right if it is done well. Okay, and all of that will now become new data. Now, when it comes to the model training, the model is an intelligence system that learns from a lot of correct answers, a lot of correct answers to be able to train itself or become intelligent. Now, because this is a very large project or large data set, if it is done well, it will be able to achieve its goal. Although it is possible that some of the pseudo data set or data will be wrong. It is possible. However, most of them are supposed to be right. And that will come from the first training. That will come from the first training. That will come from the first training. And we will go through the machine learning model process, and we will get to a point where we will understand that after a model is trained, it goes through additional processes and it goes through additional testing for accuracy. So we have code that you can use to check accuracy level. And there are a number of processes it goes through for it to be a model ready for production. Okay. And so this is how semi-supervised is done. At the end of the day, if you look at it, it is a kind of supervised learning because the unsupervised portion of it was made supervised through pseudo labeling. And so at the end of the day, the real model is trained with label data, with original labels and the pseudo labels. All right. Semi-supervised learning is a technique where a model is initially trained on a small labeled data set, then used to generate pseudo labels for unlabeled data. The labeled and pseudo labeled data sets are then combined to retrain the model, improving its overall performance. Semi-supervised learning, or SSL, is actually very common in large real-world machine learning projects, especially when labeled data is scarce, expensive, difficult, time-consuming, or practically impossible to obtain, or practically impossible to manually label. This is called semi-supervised learning. If you understand it, put 3 in the chat. If you don't understand it, please put 1 in the chat. If you understand it, please put 3 in the chat. If you don't understand it, please put 1 in the chat. Okay. All right. Okay. So actually, at this point, I'm going to call somebody who has understood it to tell us how you understand it. Okay. Tell us how you understand it. And I want to see if this is really, really understood. Okay. So we have 2 or 3 people who have not gotten it, and we want to help them to understand. So this is called semi-supervised learning. If you want to speak, please raise your hand. I'm going to enable your mic, and I'm going to allow you to speak. The beautiful part of this type of learning is that it is actually very common in real-world, large machine learning projects. Because we all understand that some of the data sets, it is practically impossible to manually get humans to label all of them. I mean, it will take 10 years to finish labeling them. We don't have that 10 years. All right. So this is an approach where we can train the model and use a trained model to train the rest of the data, and then use all again to do the retraining. All right. So we have some few hands up. Let me call V. So V, introduce yourself. Tell us where you are calling from and answer the question. So try unmuting your mic. If it works, let me know. Okay, try unmuting your mic now. If it doesn't work, let me know. And okay, let's try it this way. Okay, so please try again. Try unmuting your mic and let's see if it works now. So tell us your full name and where you are calling from. Please try unmuting. And it should work now. If it doesn't work now, then you'll have a problem. You need to either rejoin. Okay, let me ask Naomi, and then we will see if V can log out and log in again, because I've given you all the rights. It should work. So Naomi, try unmuting and let's see if it works.
Okay, good evening, everyone. Can you hear me?
Yes, we can hear you loud and clear.
Okay, from my understanding, the semi-supervised learning, it's the most commonly used in real-world ML process, and you find it becomes useful when the data is scarce, the labeled data is scarce, expensive, difficult, or impossible to obtain all manually labeled. So you'll find that you have a small amount of the labeled data, and then combined with a large amount of the unlabeled data, which you give to the ML model, it gives us a pseudo-labeled data set. That means this pseudo-labeled data set is being created from the small labeled data set that we already have, which now it's used now to label now the large amount of unlabeled data set to create now the pseudo-labeled data set. So our end product that is on the ML model trained will have both the ML trained model trained on labeled and pseudo-labeled data set, again, which was created now from previously, like I explained, and that's what we will end up with. That's how I get it.
Okay, you've done so well. Let's put our hands together for Naomi. And a few questions for Naomi. Yes, so let's put our hands together for Naomi. The unlabeled data set, can you repeat what we do with this unlabeled data set? So the unlabeled data set, can you tell us what we do with it? Okay. So V, if you're back, please raise your hand. Let's hear from V too. So I just needed some clarity, but let's listen to V. And after that, we will clarify everything. So V, try unmuting and let's see if it works this time. Supposed to work. Okay. So at the top right window, you see mic. You need to click on it to unmute. It should unmute. It should unmute. Okay, so V is not able to unmute. Anybody else who wants to add to it? So we have someone. Please mention your name. Try unmuting. Mention your name, where you are calling from, and explain it to us. Okay, so yeah, thank you. Okay, we can hear you. Okay, so Darlington, please try speaking and let's see. Your mic is unmuted. Oh, V is not able to unmute. Darlington, you have been unmuted. Try speaking. Okay, we can't hear you. I don't know if I'm the only one. Okay, so okay, so V, I don't know why it's not working. Let's try one more time. Log out and log in. And for Darlington, we can't hear you at all. Okay, so I just want us to be clear on this, and then we will be able to move forward. All right, so this is the semi-supervised learning. And at the end of the day, you can see that it is more like supervised learning, because although all the data is unlabeled, at the end of the day, we label it, and then we then use the pseudo-labeled together with the labeled to perform the final training. Okay. All right. So I wish someone had explained this thing again, but I think we've made a lot of progress here. We've made a lot of progress here. All right. So this is it. So if you look here, let me reshare my window. If you look here, we have this particular data set, which was used to train this model. So now we have this machine learning model. Now, this machine learning model, it was trained on this particular data set. So this is one type of machine learning. Who can tell me the type of machine learning we have achieved? We have achieved with just these parts. What type of machine learning have we achieved with these parts? So let me see. It's called supervised. Thank you, Anozi. Thank you, Marasi. Thank you, Nkululeko. Thank you, Benedict. This is called supervised learning. We are done achieving supervised learning. Then we use our supervised learning model, which is a functioning model, to predict. We use it to predict this unlabeled data. You see, when we have a model, the purpose of the model is to work. So let me give an example. Let's say we are building a classification model that will classify between cats and dogs. And this classification is actually done through learning from a lot of features. Okay, the weight, so many features together, then we say that this is a cat. By looking at the features, this is a cat. So the model here is trained, this model is trained by learning from this label data all the possible features of cats and dogs. So it knows a lot. Although it is not production ready for the global market, it knows cat and dog by learning from this. All right, so this unlabeled data doesn't know what is cat or dog, or we have not labeled that this is cat or dog, but we have all the features. So we use this particular unlabeled data as test data. So this is test data. And this test data, we want our model here to predict its features, its target for us. We want to use this as features to let this model here predict it for us. So we just feed it with all the features we have. And the model here is able to predict for each single data and say that this is cat, this is dog, this is cat, this is dog. And we actually save the answer and attach the answer to all of these. So for all the data items, we attach all the answers to it. Now, because the answers were created from a model, not from a human, we have a terminology for it called pseudo data. So at the end of the day, this particular unlabeled data will become labeled at the end of the day. But it was labeled by a machine and not labeled by a human. So Newman, you get it now. This pseudo label was labeled by a machine, but not labeled by a human. Newman, I hope you've gotten it. Thank you. Now, we will use the machine labeled data plus the human labeled data together as the training data. And we will come back to the same model. This model you see here is the same model here. Is the same model. Just that we now have a lot of data because out of the numerous unlabeled data, most are correct. And last week, we learned that the model is not intelligent through prediction, but it is intelligent through what? Who can remember from last week? It becomes intelligent through what? Through training. Thank you, Newman. Okay, so after we get numerous answers, and most of the answers are correct, we combine the artificial answers or the pseudo answers with the correct answers, and we now have a large data set that is now labeled. We combine them and we use all of them to now train the model or retrain the model or fine-tune the model or improve the model. At the end of the day, the model has now become super intelligent and it can now classify 100% cat and dog. At least, let me just say 100% for now. Unlimited training. So by this time, we now have a lot of data to train the model now. So all the predictions it did between cat and dog, you can see the different colors. Let's use cat and dog classification as an example. All the predictions it didn't become intelligent through the predictions, but most of the predictions are correct. or the predictions are correct. But because we really want to make it smarter, we now take the result of the predictions that we have saved and we add it to our original data and we use it to now train it. And so this is a time that it actually becomes more intelligent. It didn't become more intelligent after working for so long. So from last week's lesson, we said that even if it keeps predicting, it will not be intelligent because it becomes intelligent through training, not through prediction. So this time, from the result of the predictions, we will now do a retraining so that it will now be intelligent and we can now move it to production and use it in the real world. And this is how most real world projects are developed. And this is a type of training and it's very, very common. All right. So Newman, if you understand it now, please put 3 in the chat if you understand it now. I'm sure by now it should be clearer. Thank you. All right. So we are going to take a short break, 10 minutes, and when we return, we will move on to another type, last but not the least, called reinforcement learning. Thank you, V. Thank you, Leko. Thank you, David. So we'll take 10 minutes break and we'll come back. Please get up and stretch and rejoin in 10 minutes. Don't go off, just be back in 10 minutes and we'll continue. All right. So this type of machine learning is called reinforcement learning. We have understood the semi-supervised learning, and we've understood that it actually falls between supervised learning and unsupervised learning. And at the end of the day, it becomes more supervised. And so this is why it is not part of the 3 main types of machine learning. And so we want to look at the 3rd main type of machine learning after looking at the supervised process. So with this particular lesson, we are understanding the process of machine learning training. So we've seen that there's a supervised process. We have the unsupervised process. And the semi-supervised, we've seen that it's actually a supervised process. And it uses part of unsupervised process. So we know them already. All right, we know those processes already. Now we are coming to look at a new process, a new type of machine learning, which is called reinforcement learning. And if you are ready, please type reinforcement learning in the chat for me, reinforcement learning. So this is a new type of machine learning we want to look at. And it is simply talking about how the training is done. All the types of machine learning we are looking at, they are just telling us how the trainings are done. Yes, so let's look at reinforcement learning. Now, RL or reinforcement learning is a type of machine learning where a model or what we call an agent learns by interacting with an environment and receiving feedback in the form of rewards and punishments. We will look at why this method of learning exists. Now, most of the time, in this type of learning, we call our model an agent. Because this type of AI, we have an actual agent, or we have an actual, I don't want to say person, we have an entity that is actually performing a task. And so if you have seen anything about AI agents, you will see that these AI agents are able to take action and do things. For example, ChatGPT has released what we call deep research. I don't know if you've seen it. And the deep research agent can actually perform tasks for you. You can ask it to visit a website and book a reservation. You can ask it to actually visit a website and you will see it visiting a website. All right, let's go back and explain this. With this type of machine learning, it is a type where the model, mostly referred to as an agent, is trained by the process of performing the task in a space that is technically referred to as an environment, the space that it works. And based on its actions, it receives rewards or punishments. Why would it be like that? This is because this particular type of learning learns from what happens. So if it does something and it gets a reward, it knows that it is a right thing to do. And when it does something and it gets a punishment, it knows that it is a wrong thing to do. This is a type of machine learning where the model learns through interaction and becomes smarter through interactions. This is referred to as reinforcement learning. In this type of machine learning, we refer to the model as an agent, mostly. And an AI agent is any entity or system that perceives an environment and is able to make decisions and act based on those perceptions. It can be a robot, it can be a software program, or any entity designed to autonomously perform a task. And so in the field of machine learning, there is a type of machine learning where a model can be given an environment to operate in and can be given specific or can be given the ability to perform tasks. This agent is able to learn its environment and make decisions based on how it perceives the environment. And if it makes a mistake, it receives a reward and receives a punishment. When it makes a mistake, it receives a punishment and receives a reward when it does the right thing. And through that, the model makes better decisions by trying things out and getting feedback. By trying things out and getting feedback. So this is a type of machine learning that we will be looking into. I think this is really interesting. I don't know about you, but I think this is a really fun type of machine learning. I don't know what's going on in the chat. Okay. All right. So the model becomes better by trying out things and getting feedback. Just like how we learn from our mistakes, the model improves by trying different actions, seeing what works through rewards and what doesn't work through punishment, and then using that knowledge to make smarter choices next time. All right. Let's try some examples. Reinforcement learning can be used to teach a robot to navigate a maze. So if you look at this picture here, you see there's a maze that a robot or the agent is supposed to navigate. Initially, the robot might move in random directions. All right. Please listen to this carefully because some of you are going to get jobs in robotic companies and you are going to be faced with this. All right. I'm just telling you. So listen to this part. Initially, the robot might move in random directions and you will be training the model through machine learning. So With this particular model, the agents, or this time in this example, the robot, might move in random directions and often hitting walls or getting stuck. Each time it hits a wall, it receives a negative feedback. When it makes progress or reaches a goal, it gets positive feedback. The robot uses this feedback system to learn and improve its decision-making abilities. And over time, it gets better at navigating the maze, making fewer mistakes, and finding the most efficient route. If you have started getting it, please type 1 in the chat. I want to see those who are getting it. If you started getting it, please put 1 in the chat. Thank you, Newman. Thank you, V, Marasi, Naomi, Benedine, and Ku, Luleko, David, Lois. Wow. Right. Let's try another example. Imagine you are training a dog to sit. You give the dog a treat when it sits, which encourages it to repeat the action. However, if the dog doesn't sit, you don't give it a treat. Over time, the dog learns that sitting is the best action to receive a reward, that is a treat. This is called reinforcement learning. The agent, in this example, a dog, takes action or sit or not sit and gets reward or treats or punishment, which is no treats, based on its actions. The goal is to keep taking the actions that lead to the highest reward. And so through this, it is able to understand and is able to learn. This is the third way to train machine learning models. In fields like robotics, gaming, recommendation systems, we use reinforcement learning to improve performance, making reinforcement learning a key driver in self-learning system. This is a type of machine learning that the agent or the model learns through action, and it gets feedback immediately. You see, so it has a feedback system. Through that feedback, it knows to repeat or not repeat. We also have what we call real-time decision-making agents in the field of AI. And this is how they learn, through what is called reinforcement learning. I don't know if anyone here is a mother, but I want to ask, do children learn through reinforcement learning? From what we studied right now, do children, do they learn through this process? All right, so some mothers are saying yes, a lot. Wow, wow, wow. Okay, so you can see that this whole idea of machine learning is similar to human learning. When we get to neural networks, you discover that machine learning at that level is actually built after the human brain. And that is so interesting. And it will lead us to understand a whole lot in the human brain and how neural networks work. All right. So this is so simple, and this is just reinforcement learning. And this is the final part of machine learning in this particular lesson. So this brings us to the end of this lesson. And what we have left is to build a classification model for supervised learning. That assignment was given to you to use logistic regression last week, and most of you submitted, some of you have not submitted. I want us to actually do it for the sake of the video and the recording, because the day we did it, we didn't record the class, and so we don't have it on record. So in our next lesson, we will do our best to build that classification model to be able to classify between cats and dogs. This has been a wonderful lesson. I don't know if you've learned anything tonight, but if you have, let us know in the chat. Have you learned anything new from this lesson? Anybody? Wow. Naomi says I've learned a lot. This is how our machine learning classes are and will be. You can see that as you join the classes, it becomes easier and easier and easier and easier. And with time, you realize that you understand it. You understand it and you can do it. And we are going to get a lot of opportunities through these classes. I encourage you all to join our Monday classes to learn the math behind machine learning. It's going to be very easy to understand. It's going to be very easy, and it is going to be a component that will complete the knowledge we need so that tomorrow we are not left behind. So thank you all for joining the class. Thank you all for following. Let's keep working our self-study, please. Let's do it. Again, like I said, you can see how Benedict is making real progress. We want everyone to make real progress. We want all of us to make real progress. A lot of people are making real progress. Timothy is making progress. Yampandi is making progress. A lot of you are making progress. So let's all do it. And before you know it, you've made it. Thank you all, and I'll see you in the next class. Bye-bye.